PyCharm project itself, जहाँ सारे डेटा को स्टोर कर रहे हो, and then you can access in short of time. You just have थोड़ा सा ही टाइम है, तुमने क्या किया, सारे पास का फॉर्मेट जिनमें फॉर्मेट को कॉपी पेस्ट मार के अपने लोकल डेटा में सेव कर लिया, सेइंग कि इसको बाद में आई विल रिव्यू इट. सो बाद में रिव्यू करने के लिए दिस बिकम्स रियली हेल्पफुल. इस वे में यू कैन रिव्यू इट. सो इज दिस क्लियर विद एवरीवन?
Yes, sir.
ठीक है. Next thing that we will be focusing now is what is known as the positions. So कभी कभार क्या होता है ना कि when you have a at certain positions there are certain sequences of your interest. You want कि यार मेरे को ये particular sequence चाहिए and this particular sequence is stored at this particular position. या ये sequence जो है इस position से लेके इस position तक stretch कर रहा है. Let's say from base number 3 to base number 10 ये extend कर रहा है. And this is my sequence of interest, right? तो क्या होता है? Then the way to actually access that particular sequence is stored in BioPython in the form of positions. You can access the positions of those specific sequences. So how do you do it is those positions are stored in another BioPython package which is known as sequence features. So जो features हम बात कर रहे थे उसी features में there are different kind of like positions which are there, like start position क्या है तुम्हारे sequence का, end position क्या है, what is the range over which your position is stretched out. So वो सारी चीजें तुम्हारे एक और package में रहता है which is known as a sequence feature. So to import it, what you will write is sequence and then feature. So be clear with the again the capital letter sequence and feature here. Now let's say I want कि मेरे पास कोई भी एक DNA sequence है and I want मेरे को उसका start और end position मालूम है, ठीक है. So you want to see कि किस तरीके से you will get the output, how your output will look like. So in that way what you can do is you will write import your sequence features and then let's say I define a start position. So I'll write start position. This need not to be written as start position, you can write any name. And then I will first import my sequence feature. So sequence feature, and then I'll write what is known as your after position. What after position basically does is that it basically tells BioPython that after this position, your sequence is starting, because we have defined it as a start position, right? So let's say you have a DNA sequence of 100 base pairs and your sequence of interest starts from base number 10. So or base number 5. So what you will write is you will write sec feature dot after position and then you have to define the position. Let's say I define it as 5. So what this basically does is this tells BioPython that whatever sequences that I want to work with, the starting position of that sequence is from the 5th position, right? After 5th position, it will start out. So this is your start position. Then in a similar way, you have to define an end position as well. So you will be defining it as end position, and again it will be like sequence feature dot. Now I will be using another inbuilt package known as BetweenPosition. Now there are two ways in which you can access your end position. Now what happens is before the updated BioPython version like 1.5, ये जो between position वाला package था, this was not involved. So what happened was कि you have to be really careful with the end position of your sequence. कि कौन सा position पे तुम्हारा sequence end हो रहा है, you have to define it. Now what this between position basically does is कि कभी कभार क्या होता है in your DNA sequences there are certain ends which are known as fuzzy ends. That means you don't know specifically कि कौन से position पे तुम्हारा sequence end हो रहा है. It can end, let's say कि वो sequence number 10 से लेके sequence number 12 इसके बीच में भी end हो सकता है. You don't know the specific position at which your sequence is ending. So those sequences are known having that kind of ends are known as fuzzy ending sequences, right? So उसके लिए इन्होंने एक और package लाया which is known as between position. Now in between position you have to define कि कहाँ पे तुम्हारा position end हो रहा है. Let's say I want कि मेरा position जो है वो 9th number position पे मेरा DNA sequence end हो रहा है. After that you have to define the lower range and the upper range. कि वो 9 तो समझेगा, लेकिन उसके लिए उसके पहले ये समझना पड़ेगा कि lower range and upper range क्या है, जिसको consider करके ही वो DNA sequence को वहाँ पे end करेगा. So basically your lower range is defined as your left, and then you have to define it. Let's say I define left as 8, and then your upper range will be your right, and let's say I define it as 9. So what basically this means is कि I want my end position. That means I want my sequence to end it between 8 and 9. कि वो 8 और 9 के बीच में कहीं पे उसको काटेगा, right? It will slice the DNA sequence between the position number 8 and position number 9, right? And then what I can do is I can just store all these data in another variable. Let's say I store it in known as my location. That means my DNA location or whatever location I want it to be. And then again I will import the sequence feature package, and then I will be importing what is known as feature location. That is, now that I have defined, क्योंकि अभी मैंने start position and end position अपने DNA sequence के लिए define कर दिया है, what I want now is कि जो मैं नया variable store कर रहा हूँ, नया variable जो मैं define कर रहा हूँ my location, उस location में उस particular DNA sequence के feature को store करना है मुझे. So for that, first I will be importing sequence feature, and from that sequence feature I will be importing another package known as feature location that will basically tell my location कि this is the start and end position of my DNA sequence. क्या हो जाएंगे? The argument will be the start and your end position जो मैंने define किया already. So argument will be start position and your end position, right? And then you can just print, say, my location, right? So once you print it, you will get something like this. Now what this output basically means is, first is a greater than symbol. That is because the first thing that you have defined is a start position, and you have defined it saying that your start position is after the position number 5 of the DNA sequence. So this says more than 5, that means your start position is greater than 5. So obviously 5th position के बाद ही तुम्हारा sequence start होने वाला है. And then you have your end position saying कि मेरा end position जो है that is between 8 and 9. So 8 arrow 9. 8 cap 9. So this basically means कि जो तुम्हारा ending position है that is between 8 and 9. So this basically gives an idea about any DNA sequence. Let's say you are working with a particular DNA sequence and you know कि this is my specific area. So you can just write your start position and an end position, and in this way you will get a shorthand output. So this shorthand output basically gives you an idea key, because just looking at this output you can know key what this first symbol means, what this number stands for, what this number stands for. So this will give you an idea saying कि okay मेरा जो DNA sequence है वो 5th position के बाद start होगा and 8 and 9 के बीच में कहीं end होने वाला है. That means कि उसका fuzzy ending है, क्योंकि specific ending नहीं हो रहा है. I don't have a specific end location. So that means कि जो मेरा DNA sequence जिसके साथ मैं काम कर रहा हूँ that has a fuzzy ending which is not sure कि वो 8 पे खत्म होगा या 9 पे खत्म होगा. It can end between 8 and 9 as well. So that's why it is showing as 8 cap 9. Now sometimes what happens is, if you are working with an older version of BioPython, or let's say you don't want your fuzzy ends, okay, you want a specific ending location or a specific start location, what you can do is you can just write another command saying instead like you will be printing my location. So here while printing my location, it gave me this output which basically contained the fuzzy location. Let's say I don't want a fuzzy location. So in that case, what you want to do is first you have to access your my location, this one, and then with my location you can just write no fuzzy underscore start. So this will give you the specific start sequence कि कहाँ से तुम्हारा DNA sequence start होने वाला है. In a similar way, you can access your my location, and then you can write no fuzzy underscore end, and it will give you a specific ending कि कहाँ पे वो तुम्हारा sequence जो है वो end होगा, and you can just print it and it will show you the specific output saying 5 and 9. So your start location is 5 and your end location is 9. So this is only true if either if you are working with a older version of BioPython, तो वहाँ पे क्या हो रहा है between position वाला package available नहीं है. Then you have to be specific. Otherwise, if you are using an updated version of BioPython and you don't want a fuzzy ending or a fuzzy start, then you can just be specific in this way, right? Writing like dot no fuzzy end, dot no fuzzy start and end. So it will be a specific DNA sequences. Is it clear with everyone?
Yes, sir.
So my question is, what is the entire point of doing it? Like, I'm not understanding why we are doing.
So let's say you have a DNA sequence, okay, which is let's say 1000 base pair long, okay, and I have given you an idea saying in this 1000 base pair long DNA sequence, your DNA sequence of interest is somewhere between 500 to 600. Or I'll say that this is the particular DNA sequence. I will give you a DNA sequence saying that ATGC, whatever it is, a sequence is there, and I'll say that it is starting from position number 10 and ends at position number 100. Okay, Now what I want is, I want you to access that particular DNA sequence and do whatever experiment you want, right? For because what happens is sometimes is, let's say you have what we say is SNPs. I guess you have heard of the term SNPs, single nucleotide polymorphism,
Yes, sir.
Yes, sir.
right? So what happens is sometimes in a DNA sequence when you have, there are certain SNPs in between the DNA sequence. That means कि अगर let's say हमारे पास 1000 सीक्वेंस का 1000 बेस पेयर का एक सीक्वेंस है, तो उसी 1000 बेस पेयर सीक्वेंस में कोई एक ऐसा सीक्वेंस होगा which will correspond to a specific SNP, ठीक है? And I want you to isolate that SNP. So उसके लिए मैं क्या करूँगा? I will give you, there are two ways. If I know the start and end position, I can give you that, saying कि ये मेरा start and end position है, and just isolate the SNP. Otherwise, what I can do is I can give you an index number, a specific index number saying that this is the particular index number of the SNPs, and isolate it from that point. So what basically this whole process does is, it allows you to access a specific sequence of your interest, and then it becomes easy for another person. Let's say I don't know what you are doing, okay, but I'm very much aware about the bioinformatics. Now you have given me, in this way you have like sliced out your DNA sequence of interest, and you tell me कि okay, इस DNA sequence पे काम करना, and position number 5 से मेरा DNA sequence of interest चालू हो रहा है, and position number end पे खत्म हो रहा है. So now it becomes really easy for me to understand कि okay, what is the specific sequence with which we want to work in our upcoming experiments, या जो भी experiments में मेरे को काम कर रहे हैं. Okay, let's say if you don't want be specific, you're not specific, you're not giving a dot no fuzzy start or dot no fuzzy end, okay, and you're giving me an output जो हमको पहले मिला था, like in this way, and you share me this particular idea, okay. On an email you shared me this. Let's say मैंने we are working on the same sequence, and मैंने तुमसे पूछा कि यार okay, DNA sequence क्या है, हमारा interest का sequence क्या है. So on the email you just shared me this particular thing. Okay, so this will give me an idea that okay, the sequence on with which we are working, the sequence will start at like after 5 and it will end between 8 and 9. Okay, so this will give me an idea, okay, कि ये particular sequence पे हमें काम करना है. So I'll isolate it or I'll slice the particular sequence accordingly. Okay, so that is how you can like be in conjuncture with both the dry lab as well as the wet lab. That is what basically this positioning thing does. Is it clear, or should I explain it again?
Yes, sir. Yes, sir. It's clear. Thank you.
So now one more thing that we have to see is okay, let's just look at for SNPs. Okay, so what happens is, let's say we want to find a specific SNP in our DNA sequence, and I want कि let's say मैंने वही वाला फाइल एक्सेस किया जो हमारा अभी तक हमने जो GenBank में फाइल एक्सेस किया था. Let me just access that particular file and find a specific, whether a specific SNP is there or not. So what I'll do is I'll first import my sequence IO from my bio, and then let's say I define it a variable saying SNP, and I've given a specific index. I just want it to be like, this could be a random number, but sometimes what happens is, you know, the indexing, specific indexing, you know, when you go to an NCBI database or a GenBank database, you in the detail format, in the features format, you have the specific features saying that this is the particular position for your SNP, or this is the index number for your SNP in the whole DNA sequence. So let's say for our specific file that we want to access, the index number of the DNA sequence or the SNPs is 4350, and I want what I want is, I want to check if my DNA sequence, the one that I will be accessing, if SNPs are actually present in that GenBank sequence or not. So what I'll do is, I'll just first create a record file saying secIO dot read, and then I'll access the file, the GenBank file. It will be nc_005816 .gb and then GenBank. So I've accessed the file, and then I want to check. So what I'll do is, I'll loop throughout the sequences. So instead of specifically looking at a specific index, what I'll do is, I'll allow BioPython to loop throughout the sequence and give me the idea whether SNPs are actually present in this particular DNA sequence or not. For that, what I'll use is, I'll write for features. Now this could be anything. You don't have to write feature, it could be anything. I'm writing feature here because SNP is basically a type of a feature in a DNA sequence. That means it is a feature of a DNA sequence to act as an SNP, or single nucleotide polymorphism. So that's why I'm writing feature. It can be anything. So for feature in record dot features, Now this record dot features basically has to be universal. This will be the same thing that you guys will be writing. This can change, but this cannot change, because from record you're actually accessing the individual features to see whether SNPs are actually present there or not. So that's why we have written for feature in record dot features. If I'm using an if loop saying that if my SNP that I've defined, if my SNP is present in feature. So first what this loop will does is it will go through the features list of this record. That means from this particular file, whatever features are there, it will record, it will go through all those features and will be saving it this in this particular feature variable. And then I'm running another loop saying that if my single nucleotide polymorphism is actually present in this feature, then it will print me the whole detail of the SNPs. Okay, so I'll print saying modulus s, and then I will also to define what this modulus s basically stands for. So this modulus s basically stands for your string, as we have already seen in Python. So I have to define it as well. So I'll write modulus, and then for first I will write it as a feature dot type. That means it will give me the type of feature that I am accessing. And then for second modulus, I will be writing feature dot qualifiers dot get, and I'll tell you what this basically does is just let me write it db underscore xrf. Okay, and I'll just print it. So you can see what the output that I got is, first it has given me a source, that is the taxon, that is the basically GenBank file that I'm accessing. So this is the taxon, this is the gene ID for that, and I am getting basically two types of features because I've accessed two features for this SNP. First is the feature type. So for the feature type, it has given me, so basically this is a coding sequence, that's why CDS came here. And the feature type, so this is the feature type saying that 4547, whatever number it is, this is the number at which it will be present. And second thing that I accessed was feature.qualifiers.get. What this basically function does is it will allow you to get your specific ID for that SNPs. So that's why we are using dot get function, and this db underscore xref, what this stands for, db stands for database and ref stands for xref, basically stands for your reference. So from the database, you are accessing the specific reference for this particular SNPs. So that is what it is given you here is gene ID, that is for this specific SNP indexed at 4350. This is the corresponding gene ID of that SNP. So in this way, you can check it. Let's say, for example, I don't know if it is at 4350. Let's say I think it is at 4000 and I want to check it, whether it is present at 4000 number or not. So what I'll do is I'll just run it and I'll see the output that I'm getting is only the source. So because I'm not getting these things, because at position number 4000, there is no SNP available only. So that's why the output that I'm getting is only the source. That means it is only providing me with the source or the taxon ID number. It is not giving me the details of the SNPs that I want, because no SNP is actually present at this position, right? So these are the basic features that you will be working with. Like the features, like the ability of a DNA sequence to act as an SNP is a feature of that DNA sequence. So in that way, you will be working, or palindrome to act as a palindrome is a feature of that DNA sequence. So these are the different kind of features that we will be working with. So is it clear with everyone how you can access specific SNPs from GenBank data or an NCBI data?
Yes, sir.
Okay, so what I'll do today is I'll update the assignment up until now, whatever we have done using BioPython. Also, I'll be uploading that specific code which was asked, like to change all the T's in a DNA sequence into G's. We will also be using, I will updating that as well. Okay, so you guys please try to, I think you will be able to solve some of the questions, specific basic questions will be there. So I think you will be able to do that. I'll upload it on my GitHub account and I'll let you know in the group as well. Okay.
Okay, sir.
Okay, thank
Sir,
you.
just wanted to ask one more thing कि
हम्म,
अगर हमें suppose features पता है, हमें कोई organism निकालना है, मतलब मुझे नाम नहीं पता, मुझे सिर्फ ऐसे है कि मेरे को features है, एक specific set of features पता है कि मुझे ये specific physical properties या chemical nature है organism की, और मुझे इस type की chemical nature या physical nature के organisms ढूंढने हैं, तो वो भी हम बायोपाइथन से कर सकते हैं या उसके लिए हमें डेटाबेस ही सर्च करना पड़ेगा उठा के?
उसके लिए ज्यादा इजी बायोपाइथन से वो कर सकते हैं, बट देन आई वुड रिकमेंड कि ज्यादा इजी अपना ये रहता है डेटाबेस रहता है, बिकॉज व्हाट
अच्छा।
हैपेंस इज कि डेटाबेस में तुम्हारे पास ऑलरेडी वो फीचर्स दिए रहते हैं ना, लाइक ऑन योर लेफ्ट हैंड कॉलम जब हम फिल्टर्स लगाते हैं तो वहाँ पे ऑलरेडी तुम्हें फिल्टर्स दिए हुए हैं कि तुम्हें क्या स्पेसिफिकली चाहिए, लाइक ह्यूमंस के लिए चाहिए या फिर बैक्टीरिया के लिए चाहिए या ई कोलाई के लिए चाहिए। तो वहाँ पे क्या होता है, इट बिकम्स इजी फॉर द यूजर टू आइसोलेट द स्पेसिफिक डेटा। बायोपाइथन में क्या हो जाएगा, यू कैन डू द सेम थिंग, लेकिन यहाँ पे लाइंस ऑफ कोड यू हैव टू रन लार्ज अमाउंट ऑफ टाइम, वो
तो
एक थिंग है,
टीडीएस वर्क हो जाएगा।
बहुत टीडियस हो जाएगा। एंड सेकंड थिंग इज कि तुम ऑनलाइन भी कर सकते हो, लेकिन ऑनलाइन बहुत टाइम लेगा क्योंकि बहुत लार्ज अमाउंट ऑफ डेटा तुम्हारे पास है। फॉर एग्जांपल यहाँ पे इसने इजीली इसलिए रन कर दिया क्योंकि हमारे पास एक स्पेसिफिक फाइल था जो मैंने लोकल अपने लैपटॉप में स्टोर किया हुआ है, ठीक है, और मैंने उसके स्पेसिफिक फाइल से मैंने ये ढूंढ के उसको आंसर पूछा कि SNP अवेलेबल है या नहीं है, व्हाटएवर इट इज। बट व्हेन यू विल बी यूजिंग इट ऑन अ सर्वर तो तुम्हारे पास लार्ज अमाउंट ऑफ डेटा है क्योंकि बहुत सारे ऑर्गेनिजम्स हैं, तो देन इट विल बिकम अ लार्ज वेरी टीडियस जॉब। उसके तुम्हारे पास लैपटॉप का रैम बहुत तेज होना चाहिए, नहीं तो अदरवाइज योर लैपटॉप विल गेट स्लो डाउन। अगर रैम ज्यादा तेज नहीं है तो लैपटॉप स्लो हो जाएगा फिर, क्योंकि लार्ज अमाउंट ऑफ डेटा को वो सिमुलेट कर रहा है, ढूंढ रहा है उसमें से। सो देन इट बिकम्स क्वाइट इजी फॉर द यूजर टू डायरेक्टली गो टू द डेटा सर्वर एंड वहां से जो फिल्टर्स है वो लगा के चेक कर लो कि स्पेसिफिकली कौन सा हो जाता है। बायोपाइथन से कर सकते हैं लेकिन बहुत टीडियस हो जाएगा क्योंकि लार्ज अमाउंट ऑफ कोड्स तुमको लिखने पड़ेंगे इसके, ये इशू रहेगा। एक बार बार फॉर लूप रन करते रहो, फिर इफ कंडीशंस देते रहो कि ये होगा तो कोई आउटपुट होना चाहिए, वो बहुत ज्यादा टीडियस जॉब हो जाएगा फिर।
हाँ सर।
Okay, then see you tomorrow, and I'll update the assignment and let you know. Okay.
Thank you,
थैंक यू
sir.
सर।
Okay. Thank you. Have a nice day.